We are live now, my dear friends. We are live now. After so much time, we are again live. So today, my dear friends, our topic is photoelectric effect. This is our topic, photoelectric effect, that we are going to do today. Today, this is the topic that we are going to do today. It's today. Today we are going to the topic photoelectric effect. Photoelectric effect. This is the first topic. You can say that we are doing the chapter dual nature of radiation and matter. From that we are doing our first topic, that is called photoelectric effect. Photoelectric effect. So this is about me. This is about me, myself. This is me, Raghav Sharma. Raghav Sharma, teaching experience 3+ years, MSc Physics, BSc Physics, B.Ed, work published in International Journal, and work done with the researchers in GNU. I have done that work. So this is about me. This is about my. This is about me, my dear friends. You should know that who is teaching you. And do tell me, how's the preparation for the exam going on? How's the preparation for the exam going on? You can just rate it from 1 to 3. If it is going bad, you can rate it 1. If it is going, okay, then there is an option of 2. And if it is going good, then you can just rate it 3. So from between 1 to 3, you can rate it 1, 2, 3. You can do that. It's on you. It's on you, the way and the how you want to rate it. How you want to rate it. 1, 2, 3. It's on you. Now, my dear friends, now my dear students, what is the goal? What is the goal that we are going to do today? What is the goal? First we will study, and I will tell you actually what is the dual nature. What is the dual nature first? After that, what we will do? We will do photoelectric effect. After that, we will do photoelectric effect. After, we will study particle nature of light. Particle nature of light, that is important. Emission of electron from metal surface. Emission of electron. After, work function. And after that, we will see threshold frequency and threshold wavelength. And while doing all these things, we are going to do the conceptual questions and previous year question. Conceptual question and previous year questions. Got it? So these are the things. First, an introduction. An introduction is necessary. How the things are made up. Introduction necessary or not? Yes, it is necessary, sir. Then photoelectric effect, particle nature. Photoelectric effect shows particle nature. Then emission of electron, and we will do some terms related to the photoelectric effect. And that will be all for today. For today, that will be all. That will be all for today. So first thing first. If you haven't subscribed to our NEET channel in the Telegram, if you haven't subscribed to the Telegram channel of our NEET, of our Altedemy in Telegram, make sure that you are following it. Then we provide PDF material, do announcements, and give discount prices. Many students we have in past given the free subscription courses plans of our free. Just why? Because they are following us. Make sure you are subscribed. Make sure you have that. And what is the courses? 90+ classes, convenient education platform. You can access from everywhere. Syllabus made by the NEET experts. We have flipped classroom method. I will explain that thing at the end. At the end, what is flipped classroom method? And we do DPP regularly, so make sure you are in sessions. Make sure you are in the sessions of the DPP. That things are important. So this is the plan. We have 3 plans: light, smart, and professional. Profi. In light, we have these things. In light, smart, professionals, we have internet class, live classes, structures, PDF, live test, physical notes. These things are in all. Apart in smart and professional, we have one-to-one mentorship, live doubt solving, mock test. That thing is important. Okay, mock test, and mentorship is important. That things are important. And in professional, we have additional special courses that you can have. So it is on you that what is best for you, and according to you, you can choose any plans that is suitable for you. So let's get started. Let's get started to the dual nature of radiation. Dual nature of radiation of matter. Dual nature of radiation and matter. Dual nature of radiation and matter. Dual nature. So we are doing dual nature. So first thing. So there are 2 types of theory. One is light theory and one is matter theory. One is light and one is matter. So light theory. So light radiation. Okay. So first, on the very first, Newton suggested what? He suggested corpuscular theory. He suggested what? Corpuscular theory. It is a matter. He said that light is a matter. The light is a matter, and it's like striking. It is striking the surface. It is striking the surface. This is the theory given by whom? Newton. Newton in the 1665. After that, in 18th century, our scientist came, and there are some experiments. Young double slit experiment. There is a very famous experiments, Young's double slit experiments, and he shows various phenomena which you have studied in what? Ray optics, diffraction, polarization, interference, double slit experiment. There are many experiments he's done, and he said that light is what? Light is. So he said what? Wave nature. He proved wave nature. Wave nature. And Newton said what? Particle nature. He said what? Particle. Newton said, oh, it is particle. But Young's, when the experiments have done, Young double slit experiment, diffraction, polarization, he said no, it is what? It is wave. But in 1887, what happened? Very famous experiment happened. That is called photoelectric effect. Photoelectric effect. A very famous experiment. Photoelectric effect. And now the persons which says, hey you, wave nature guys, prove the photoelectric effect on the basis of wave nature. They tried, but they failed. And he said that in photoelectric effect, it can only be explained by the what? Particle nature. It can only be explained by the what? Particle nature. Explained by the particle nature. And after that, there is a D. Broglie, our D. Broglie guy. He said, oh, hold up. He said that it can be explained, it's just dual nature. It can be, it can act like a particle, and it can act like a wave. It can shows both nature, particle nature and wave nature. We will study that in our next lecture, de Broglie hypothesis. So first, what we are going to do today, photoelectric effect. Photoelectric effect. So what is, my dear friends, what is photoelectric effect? What is photoelectric effect? Photo means, here photo means photon. It means photon, electric. Here electric means electron. Photon plus electron. Photon plus electron effect. In short, photoelectric effect. In short, what? In short, photoelectric effect, photon plus electron effect is called photoelectric effect. It is called what? Photon plus electron, photoelectric effect. Now what happens? Now what happens in photoelectric effect? Now what happens? Now what happened, my dear friends? What happened? A very high frequency, beam. You can say light rays of frequency. You can say light rays of high frequency, just to be safe. Okay, is incidented on the what? Metal surface. On the metal surface, they are incidenting on the metal surface. Light rays of high frequency incidenting on the metal surface. Then what will happen? Electron will be emitted. Rays are coming, like say there is a ray come like this, and it has come like this. After it has struck, incidented on the metal surface, what will happen? An electron will emit. So this phenomena, the photon is incidenting on what? Metallic surface. And after the incident, an electron is emitting. After the incident, not accident, it's incident. After the incident, an electron is emitting. So this phenomena is called what? Photoelectric effect. It is a kind of electron emission process. Emission process. So what happened? When a radiation of high frequency, or low wavelength is incident on a metal surface, electron may be emitted. And this phenomena is called what? This phenomena is called photoelectric effect. This is called what? Photoelectric effect. And the energy will be, this energy the frequency, we are talking, the energy of the photon is h mu, where h is Planck's constant. E is the energy of the photon, the incident photon. Energy of incident photon, and mu is the frequency. 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 Mu is the frequency. Frequency of the photon. Are we clear? Are we clear till now? Are we clear? So there is a famous formula like E is equal to what? H mu. H mu, H mu, H mu. And mu is what? Mu is C upon lambda. Mu is what? Mu is C upon lambda. So HC by lambda. Now I am going to write one thing, and you have to remember that. You have to remember that. Please make sure that you do remember that. If it is equal to 1240 upon lambda, lambda is the wavelength, that is in nanometer, and energy is in electron volt, so you have to remember this. Just the basic calculation, I put the value of H, Planck's constant, value of C, speed of the light, lambda in nanometer, and energy is in electron volt. We calculate the energy in what? Electron volt. We calculate the energy in electron volt. Are we clear? Are we clear? Are we clear? Yes, we are. So make sure you know this. Just a simple mathematics. Where were you missing for so long? Actually, we are preparing the materials and the things. We just got busy in the our classes that we are giving in our platform. So we became very busy on that. So, but the students are saying, sir, where are the classes? So we came back and giving the classes in YouTube and doing YouTube webinars for you. So this is the energy. So now let's do the particle nature of light. Let's do the particle nature of light. Particle nature. So the energy which has came, okay, what is the particle nature of light says? It says the particles of lights, the particles of lights are called photons. They are called photons, or energy packets, or quanta of energy. They called what? Energy packets, quanta of energy. So they are like vibrating energy back. They travel like energy back. Like you're shooting a gun, a bullet. So they are energy packets that are traveling. They are called what? Energy packets with the frequency of mu, or you can say with the wavelength lambda. They are called energy packets. And the mass of the photons cannot be defined in Newton mechanics. They can't be defined, that part is clear. And the mass of the photon is 0. The rest mass of the photon is 0. This means the photon cannot be in rest. The photons cannot be in rest. It is always moving. It is always moving with some velocity, that is c, speed of light. Will have some energy. It is traveling with the speed of light, so that's why it can't be defined by the Newtonian mechanics. With the Newtonian mechanics. And his speed is what? The speed of light. His speed is what? The speed of light. That is what? 299,792,458 meter per second, or you can say 3 into 10 raised to 8 meter per second. For easing things up, we can say that. That make things easy. And photon in the fourth point, a photon is chargeless. A photon is chargeless. It has no charge. It has it has no charge. Place that in place that in energy electric field. It will have q is for the photon is 0. Q for the photon is 0, so it will face no force due to the electric field. And similarly for the magnetic field, it has no charge. It is chargeless. It has nothing. It is only energy. It has only energy. It doesn't have any mass. It's just energy. It's just energy traveling from one point to another. Just the energy. It is just the energy that is traveling. Nothing more. Nothing more. Okay, this is the energy that is traveling. If force, magnetic force Q, V cross B, magnetic force Q, charge is zero. So the magnetic field also zero. Magnetic fields also, magnetic force also zero. Magnetic force also zero. Okay. I think things are very, very clear. Things are very, very clear. So after that energy, we have talked about energy. Energy is h mu. So energy of the photon is directly proportional to the frequency. It is directly proportional to the frequency. And you can say C is equal to frequency into a wavelength. So if we replace that, it will become energy of the photon is inversely proportional to the wavelength. It is inversely proportional to the wavelength. Okay, are we clear? After that, each photon has definite energy and definite momentum. Each of the particle will have definite energy and definite momentum. What it means? What it actually means? Definite energy. Energy is what? I have told you. H mu. What does H mu means? This is the frequency. Frequency will be something. Or in terms of frequency will be something. So it will have definite energy. It is going to be will have definite energy. And what is momentum? Momentum is h upon lambda. Momentum is what? H upon lambda. The photon will have its definite wavelength. So it will have its definite what? Momentum. It will have its definite momentum and definite energy. And we can define the energy in case of what? In case of wavelength, what it will be? 1240. Writing this thing again. These things helps very, very much. 1204 energy in electron volt and lambda in nanometer. Lambda in nanometer. Lambda is wavelength of radiation. H is Planck's constant. And its value is 6.626 10 raised to minus 34 joule second. You should remember that value too. 6.64 or 6.626 10 raised to minus 34 raised to minus 34. Are we clear? 6.626 into 10 raised to minus 34 joule second. Are we clear? Are we clear, my dear friends? I think pretty easy stuff. Nothing so much hard. 6.626 into 10 raised to minus 34 joule seconds. So what we have done, I have told you the energy of the photon, that's h mu, and in terms of wavelength 1240 electron volt lambda Newton meter. If in this solution the energy will come in what? Electron volt. Energy will come up in electron volt. And this is the momentum. This is the momentum h by lambda. Lambda is the wavelength of radiation. So a photon will have its definite lambda, or you can say definite frequency. So we are clear up to till now. After that, let's do the question. So we have a question. A 2 millivolt laser operates at wavelength of 500 nanometer. The wavelength is always going to be in Newton meter or in angstrom. If in angstrom, convert into what? Into nanometer, and then just put the energy formula, and things will be very much easy. So he's asking the number of photons that will be emitted per second is the number of photons that emitted per a 2 millivolt laser. So in 1 second it is emitting what? 2 millivolt power. 2 millivolt power. Energy emitted. Energy emitted. Energy emitted is equal to the energy emitted is emitting what? Radiation. It is emitting photons. So the number of photons is equal to photons energy. Energy emitted is equal to number of photons and that they are emitting per seconds, and into the energy of single photon, energy of one photon. So this we want to know. This we want to know. Number of photons. Now we have the energy emitted. Power. This is the power. Power is what? E by T. T is 1 for 1 second. For 1 second, E is equal to P. So energy emitted will be 2 into 10 raised to minus 3 millivolt is equal to n that we want to calculate, and the energy of one photon in Newton meter or nanometer. In nanometer we know, so it will be 1240 electron volt, 1.6 10 raised to minus 19, and lambda in nanometer, so 500. We have to calculate that. So n will be. So let's cut some 0. 0 0 0 0. So 1.6 and what can be happen? So let's do the calculation. 50 and 90. Let's move 50 here. 50 to the 100 will be here. 100 10 raised to minus 3, and n will be 124 into 1.6 10 raised to minus 19. Electron volt 1.6 10 raised to minus 19. So 10 raised to 2, 10 raised to minus 3, this is 10 raised to minus 1. So 10 raised to minus 1 will be upon 124 1.6 10 raised to minus 90 is equal to the n, that's the value we want. This is the value we want. And after they will do calculation, after we do the calculation, it will come out as at nearly 5 into 10 raised to 15. Just doing the things easy way, because I know the answer. So after the calculation, we will get this answer 5 into 10 raised to 15. For doing the things easy way, because I don't want to waste the time in calculation. 5 into 10 raised to 15. If we solve this, the answer will come out as 5 into 10 raised to 15 approximately. Answer will come this. Are we clear? Pretty easy stuff. We can solve this. 120, 124, take this 125, 1.6, and do the calculation. Approximation by approximation, we will get this. After that, the question is, if the intensity of radiation incident on a photo cell will increase 4 times. This is the thing that we are going to do after this. So if the intensity of radiation of photo cell will increase 4 times, then the number of photoelectrons and the energy of photoelectron emitted respectively becomes. What will happen? We are increasing the intensity. Okay, 4 times. What does the intensity means? Intensity means the number of photons are going to increase. By what factor? By the intensity is increasing. So 4 times. So the photoelectrons, the number of photoelectrons that are going to emit, are also going to be 4 times. What does the incidence mean? Intensity means we are emitting 2 photoelectrons. If we increase the intensity 4 times, then what? 4 2 into 4, 8. We will have 8 photons. Then we will have what? 8 photons. We increase the intensity. Then what will happen? The number of photons will going to be increased by that particular amount. 2 times intensity 4 times, so number of photons increase 4 times. Okay, 4 times. Yes, that is okay. That is correct. So C and B are wrong. Then the energy is going to remain same. Energy of the photons is going to remain same. 2 photons, energy h mu. 8 photons, again energy h mu. So when we increase the intensity, only the number of photons increase, not the energy of the photoelectrons. So the option D is correct. Option D is correct. After that we have the particle nature of light. Again, we have the particle nature of light. Photons of light of a particular wavelength have the same energy, same momentum. Yes. We have done that. So photons of a light of a particular wavelength, wavelength, say a wavelength is lambda. So there is photons, many photons. There are many photons, and they all have what? They all have the particular wavelength lambda. So many photons all have the wavelength lambda. So energy is what? H mu, or you can say hc by lambda. If the h is constant, c is constant. So all photons will what? So all photons will have the same energy. All photons will have the same energy, because the only factor that is contributing is lambda, hc by lambda. So they will all have the same energy and will have the same momentum. same momentum. What it suggests? 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 The same energy, same energy, same energy, same energy, same energy. After that, we have the collision of photon. After this, the things will become clear. The collision of photon with the material particle assumed as a perfectly collision. What it means? What it means? What it means? There is a photon. Let's say photon, and coming to what? An electron. There is electron. Electron. What will happen? What will happen? What will happen? Let's say after that there will be some radiation, okay, some energy left, and plus E, energy of the photon. So let's say first the photon has the momentum p1 plus electron momentum p2, p2, and after the collision momentum become p1 dash, and of the photon and of electron become p2 dash. So what it suggests? What it suggests? This is a conservation of momentum. There will be the conservation momentum, and also there is going to be the conservation of energy. There are also going to be the conservation of energy. Means total kinetic energy initial, total kinetic energy, total kinetic energy is equal to the total kinetic energy final. But there is no conservation of photon. No conservation of photon can be there. There can be no conservation of photon. Photon can be fully absorbed. So where will that photon will go? That photon will go in electron. So there is no conservation photon, but there is a conservation of energy and momentum. That's why it is what? That's why it is perfectly elastic collision. Perfectly elastic collision. That's why it is perfectly elastic collision. After that, if the incident of the, yes, I have told you, if the intensity of the light of a given wavelength is increased, the number of photons will increase, but the energy of the each photon is still the same. Like if we have 50 watt energy, let's say at the 50 watt energy, at the 50 watt we have 4 photons with energy 12.5. Okay, let's say we have energy, skip the word energy, with same energy. Okay, of same energy, 4 photons of same energy at 50 watt. Okay, and at the 200 watt, this is 50 watt, at 50 watt, at 200 watt, let's say at 100 watt, what will happen? The number of photons will increase. Eight photons. Now we have 8 photons with similar energy. What happened? Photons photons numbers increased, but not the energy when we increase the intensity. We increase the intensity. We increase the intensity. Like when there is like a torch, we increase the intensity. What will happen? Number of photons gets increased. The number of photons that is emitting increased, but not the what intense, but not the energy of the individual photon. That what happen? And when the number of photons get increased, when the number of photons increases, you will see more. You will see more. Okay. So this is what this is that. After that, we have the emission of electron from the metal surface. The electron on the surface are slightly less bounded as compared to the electron in the bulk of material. Yes, we know. Yes, we know. Yes, we know. In surface, photoelectron emission always happen in where? At the surface. Because at the surface, the electrons are what? Less strongly bounded. They are still bounded by the energy, but the energy compared to the inner electrons, that energy is lower. So such electrons can be freed from the surface. Such electrons can be freed from the surface if they will have what? If they will have enough energy, they can break their bonds and can roam to the space and enjoy themselves. They can do that too. So that thing is on electron. Emission of electron from metal surface. There can be three type of emission. First, thermoionic emission. That is due to heat energy. Second is field emission. This is due to the what? Electric field. When we apply very high voltage, there is a very high voltage difference between two ends of the metal. So breakdown will happen and electron will move from one surface to the another surface. And third, that we are doing right now, that is photoelectric effect. Photoelectric effect. The one we are doing is the photoelectric effect that we are doing right now. I think things are easy. Now let's talk about the work function. What is work function? Let's say there is a metal surface and there is a photon came, and photon with energy h mu, and the electron that is emitted has the counting energy K E. Counting energy K. So this energy is h mu. Is h mu the energy of the photon or the energy of the counting energy of the electron? The energy that the electron gained are similar? No, they are not similar. The h mu, this h mu is not equal to the counting energy. So where is the energy? So where this energy is going on? So this energy, there is some energy that the electron is taking to get removed by the bounds. So that energy, that minimum energy is called work function. That minimum energy is called work function. Work function. Work function. Okay. This is the symbol. This is the symbol. This is the symbol. Okay. This is a symbol. And lowest work function, if we talk about the work function of the various material, we talk about okay, in electron volt energy. Let's talk about some materials. Okay, metal. So if someone asks you, you can say cesium has the lowest work function. After that we have 2.2 of potassium, and after that we have 4.5 of copper. 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 Now you have to take care of one thing more. You have to take care of the one thing more. You know that energy we are supplying, the energy we are supplying, energy. If the supplied energy is greater than the work function, okay, if the supplied energy, there is mu, if the energy that we are supplying is greater than this, there can be emission or there can't be no emission. There can be emission or there can be no emission. There can be no emission. Yes, it can happen. Yes, it can happen. And how it can happen? If it loses energy, the energy that is gained, that is like, it's like come and go. The energy, energy photons, they are in come in millions, they are millions. So it can collide with another electron. It can collide with another ion. The electron which are gaining energy, it will collide with some ion or some other electron and can lose its kinetic energy. Kinetic energy. So it may or may not. There can be both the things can happen. It will come out or will not come out. It's that depends on the luck. It depends on the luck. You say if we supplied the energy, they say supplied the energy 6 electron volt, and the work function is 2 electron volt, and the kinetic energy that is came out is 1 electron volt. 6 equal to 2 plus 1, no, it's so there is some energy that is getting wasted energy. So the energy can get waste. So it all depends. The energy can get waste too. While emitting, while breaking the bonds. It's like his father came, oh, come again. So it can have that too. So when the supplied energy is greater than the work done function, the electron may come out or may not. It all depends. So if we if we do like this, energy, make a graph, energy phi, the supplied energy, the phi work function, waste energy, and the energy that is wasted, and the kinetic energy of emitted electron. So let's say the energy is supplied 10 electron volt, and the work function is 4 electron volt. 4 electron volt. So there can be many cases, like there is no waste of energy. There can be very low waste of energy. There can be more waste of energy, and there can be very waste of energy, very much. In this case, the kinetic energy will be max when there is no waste of energy. And what it will be? It will be 6 electron volt. In this case, when there is only 1 electron wasted, their energy will be 5 electron volt. In this case, 1 electron volt. And in this case, electron will not come out. In this case, electron will not come out. In this case, electron will not come out. Electron will not come out. So when we write the equation, what equation we write? Energy given is equal to the work function plus kinetic energy max. This is the maximum energy that the electron can have. This is the maximum energy that electron can have. This is the maximum energy, okay, maximum kinetic energy that the electron can have. Energy can't be greater than this. It is the minimum energy that it can have. And after that we have threshold frequency. After that we have threshold frequency. What is threshold frequency? It is the minimum frequency. It is the minimum frequency that just it will go. So the energy is greater than the threshold. Has to threshold, okay, threshold. After if the energy we are giving is lower than the threshold frequency, then the electron is never can get emit. Electrons can never get emit. So it will has to be some minimum energy, h mu of the some frequency, some frequency, h mu, okay, phi. So mu will be phi upon h. So this is the minimum frequency, or you can say threshold frequency. This is called what? Threshold frequency. This is called threshold frequency. The frequency that we are going to give, has to be greater than threshold frequency to give an electron a chance to get out, give an electron a chance to get out from the metallic surface. If the frequency is lower than this, the electron never can get out. The electron never can get out from the metallic surface. So this is the minimum frequency that we have to give. Then let's talk about the threshold wavelength. Let's talk about what? Threshold wavelength. So energy is greater than what? Energy can written as hc by lambda. This has to be greater than this. And if we do like this, lambda, if we do this, so hc by lambda max. We just replace the lambda here and phi here. So hc, so this is the lambda max that we can have. Lambda max, if the wavelength is greater than this, the electrons are not going to be emitted. So this is the maximum wavelength we can have. Okay. Okay, my dear friends. So lambda has to be smaller than the threshold wavelength to has his work done. So the electrons can emit from the surface. So the electrons can emit from the surface. Now let's do the previous year questions. First questions. Light of frequency 1.5 times the threshold frequency. So the mu is 1.5 times the mu naught. On a photosensitive material, what will be the photoelectric current if the frequency is half? Now the frequency, this is initial. Now this is mu1, mu2 will be half of this. So this will be 1.5 means 3 by 2. So this will be 3 by 4 of mu naught. So this is now 3 by 4 mu naught is actually lower than the threshold frequency. Is actually lower than what? Threshold frequency. What will happen? What will be the current? What will be the current now? There will be no emission of electrons. Now there will be no emission of electrons. And if there is no emission of electrons, the current will be what? Current will be zero. If there is no emission, then there is no current. After that, the Odisha NEET 2019. The work function of a photosensitive material is 4.0 electron volt. The work function of a photosensitive material is 4.0 electron volt. We have the work function. The longest wavelength that it can emit. Longest wavelength that it can emit. I have just written down the formula. Longest wavelength, hc by lambda. So just here and there, and 1240 electron volt Newton meter, and this is 4 electron volt. And if we cut off the things, EV cut 1240 by 4, 6 to 620 by 2, and 310 option number D. You know how easy the things are. After that we have question. When the light of frequency 2 mu naught, where mu naught is the threshold frequency, is incident on a metal plate. There is a light and has the frequency of 2 mu naught. Frequency is 2 mu naught. Is incident on a metal plate. The maximum velocity of the electrons emitted is v1. This means when there is a frequency. If the frequency of the light is 2 mu naught, then the velocity is v1. And when the velocity of the incident radiation is 5 v naught, the maximum velocity it can have is v2. So we have to find the ratio of v1 by v2. This is what we have to find. Let's first find v1. Okay. So the energy is work function plus kinetic energy, maximum it can have. So the first time energy is 2 mu naught. So H and 2 mu naught, and work function is H mu naught, and kinetic energy half mv square. So it's 2h mu naught. So H mu naught is equal to half mv square. This is the first equation. After that, for second, this is the for first. For v1. In second, it has the energy 5v naught. Work function is going to remain same, h mu naught plus half m v2 square. So 5 or minus 1, so energy will be 4 e h h h h. This will be h. This will be h. Yes. 4h mu naught will be half m v2 square. So he is saying for finding v1 by v2. So half m v1 square upon half m v2 square will be h mu naught upon 4 h mu naught. Cut m. So v1 upon v2 square is equal to 1 by 4. So v1 upon v2 will be 1 by 2. So the ratio of v1 of v2 will be 1:2. 1:2 will be the answer. Option number A. Option number A. I think easy stuff. After that, we have the question NEET 2017. The photoelectric threshold wavelength silver is this. The photoelectric threshold wavelength silver is this. We have the wavelength in angstrom. Threshold wavelength. We have the threshold wavelength. Lambda naught. That is threshold wavelength 325 nanometer. Can convert it into nanometer. 3250 nanometer. Yes, it will be this. This will be nanometer. Nanometer is a 325. Okay. And the wavelength, the silver is this. The velocity of electron rejected from a silver wavelength, and the electric wavelength, the wavelength of the ejected electron is this, 253.6 nanometer. Okay. So he is now asking for the what? He is asking for the velocity. This is the ultraviolet. This is the what is this? This is the emitting. This is the wavelength of the radiation that is getting incident in on the silver surface. So lambda. So he's asking for the velocity. So h mu naught plus half mv square. Okay. So half mv square will be hc by lambda minus hc by lambda naught, and this will be half mv square hc, half mv square hc. So we know that in lambda 1240 in electron volt, 1 upon 253.6 minus 1 by 325, 1 minus 325 electron volt in electron volt. This is an electron volt. After we solve this, this is the mass of the electron. After we solve this, this will come as an electron volt 1 0.076 electron volt, half mv square. After solving this, so the velocity will be 2 into 1.076 electron volt, 1.6 10 raised to minus 19 for 19, and mass is 9.1 10 raised to minus 31. After solving this, we will get 6 into 10 raised to 5 meter second inverse. 6 into 10 raised to 5 meter second inverse, option number D. 6 into 10 raised to 5 meter second inverse. So if we do that, 0.6 10 raised to 6 meters inverse second. Option A. Option A and option B, option D are basically the same options. So in this, in NEET 2017, A and D both are same options. So they both are correct. A and D both are same options. A and D both are same options. We can do that. We can do that. Okay. Now, how our class looks like. So first, we will provide theory. After providing the theory, we provide study material. In classes, we do previous year questions, theory, and do stuff like that in theory. After we provide study materials, we provide what? Study materials. After that, we will do webinars. And after solving all your doubts, we will provide you what? Homework. And we have the faculty sitting, I also sit and do the checking of your homework and try to solve your doubts that are remaining. So that's all for today. I hope you like it. And see you in our next lectures. Till then, take care of yourself and be safe from the coronavirus, Omicron, and be happy and be healthy. See you soon.